have in the Python. But when it comes to Numpy, we can easily overcome using a slightly different functions. So instead of a range, we are going to use a range. A range. It is not arange, it is a range. So what we will do, we'll see whether we are able to create that range using a Python. This is the Python function, range function. Here what I have, this is the starting point, comma, this is the end point, comma, this is the 0.4 is the step size. The whole thing I'm trying to convert into list. Let's check whether I'm able to generate this range of data. So it says that float object cannot be interpreted as an integer. So it means that yes, we cannot generate a list of a data, whatever the range I'm giving here, which is in the float point. So now what I'm going to do, I will take the same data without changing a single point here. Now I'm going to say np.arange. np.arange, starting point, end point, step size. Whole thing I'm storing in A and I'm just displaying that data. So let's execute this. So here you can see it started from 2 and this is the step size 0.4. So 2.4, 2.8, 3.2. So the distance maintained between one number to the next number is 0.4, that is step size. Right? So ends at 10.5. Obviously, we know that end point is not included. By the way, it is ending at 10.4 only. So we'll be able to print that as well. Right? So yes, it is possible in the Numpy because the name says it is number. You can play around with the numbers here, irrespective of whether it is an integer or a float, doesn't matter. So here we had some kind of limitations that we can overcome using a number. Right? Now, suppose I wanted to print this whole array in reverse order. Reverse order. So what you can do, this whole thing is A in the square bracket colon minus 1. I will explain this what is exactly it is. So yes, I will be able to reverse it. Right? I will be able to reverse it and how it is working actually. So now we need to understand. So let me write it in bigger fonts. So colon, I have a colon and I have minus 1. Right? So this point ideally takes starting point. And this space will take an end point. And this is basically step size. Right? So what Numpy does, whenever it sees minus 1, it will start looking from the backward direction. Right? So this will identify based on how you are going to put your step size. Since it is a minus, it is a backward direction. Okay, it is a backward direction, that is fine, but what is the starting point and end point? Since I have given nothing, it's empty, and this is also empty. So empty means what? Starting from 0, right? If I don't mention anything, it starts from 0th index. Even end point, if I don't mention anything, so it means that all data until end, everything until end. If I want to restrict, I can give here number. Now I'm not giving anything, starting from 0 to end. So now let's look into this. So starting, what is the starting point? 0. From which direction? So backward direction. 10.0. What is the step size? -1 means next point. 10. Then next point. Next point. So it will print all the data. So that is how it is working. If you want to restrict any data starting from one number to another number, you can always do that, right? So if I give, say, 3 and if I say 10, right? Let's execute this. So we don't have any data as of now. So now what I'm going to do, okay, so this is supposed to be different. So let me give 10. Okay. So now if you look into this, starting point is a 0, right? Start from here. So up to what? 10 items. Up to what? 10 items. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So in the reverse direction, it is going to print. So you can restrict based on the numbers you are going to write. All right. So that's how you can interpret here. So you can play around with these numbers and all. It's up to you. So it is just an idea how to reverse the data. All right. Fine. Simple slicing method, I would say. Now let's look into, this is basically what? A range and reversing the data. We'll talk more about this using different numbers in the first starting point and end point and changing the step size and all. We have more exercise to do on that. So this is just an overview of that one. So let's see that. Let's try to understand with one more example, a range, that reverse, right? Now I wanted to generate, we know that how to generate number from 0 to 50, right? 0, 1, 2, 3 up to 50. It's pretty easy. Even if I want to generate 0 to 50 in a 5 interval of 5, so 0, 5, if I want this kind of a data, so I can give a step size 5, right? So that is basically we know. But if I want to generate number from 50 to 0, 50 to 0 in the reverse order, right? So how will I write that one? So I'm going to use the numpy.arange. So whenever you want to reverse the data, right? I mean, generate the reverse order in reverse order. So your starting data should be high. Your starting data should be high and the end data should be 0. Then step size, however you want, you can give it. Now let's look into this, then we'll interpret. So starting point 50. What is the step size? -5. So 50 to 50 minus 5, 45 minus 5, 40 minus step size. So since the end point is 0, it is not going to be considered. It will not be considered. So until before that, whatever the data comes, it will print. Right? So what if I give a 0 and 50? What if I give 0, 50, keeping step size -5? It will not print anything. Right? So 0, what is the -5? Step -5, it is going to be -5. We don't have that range here. Right? It is not going to throw any error. It says that I don't find any data. Right? So you can play around with this number. So I'm just trying to give an idea that if you want to generate numbers in reverse order, your starting point should be high, highest number. Then the end point is the lowest number or the small number. All right. Okay, so I see a couple of questions there. Let me finish this. All right, two more functions, then I will check those questions. All right, just hold on for a minute. Now let's try to understand linspace. Numpy dot linspace. What is this linspace? Lin is nothing but linear. Linearly spaced. What is linearly spaced? So I want to generate some data for any reason, right? So if you ask that what is the use of this, so there are situations that you want to generate some numbers, right? We don't know why. So I can say that, okay, just to create a roll number. I can say create a serial numbers for the customers. If the reason could be n, right? So if at all we find, if at all we get into a situation, I need to generate some numbers, keeping equal distance between one number to the next number. So what we will do, we'll execute this and interpret the result with this linspace. So let's execute this. So what it says, linearly spaced means equal distance. What is equal distance here? First of all, let's try to understand. This is the starting point. This is the ending point. So this one is, it is not a step size. 5 is not a step size. This is number of elements, number of data points. So how to interpret this? I am saying that I want 5 elements. I want 5 elements between 10 and 40. And those 5 elements should be equally spaced. So I'm saying between 10 to 40, I don't want number like a 10, 11, 12, 13 and 14. Otherwise this 40, whatever the endpoint I have mentioned, right? So it doesn't make any sense, right? So if it's generated 10, 11, 12, 13, 14. So I'm giving this range, I want the number 5, I mean 5 elements or 5 data points between number 10 and 40. And which number? So this linspace or linearly spaced, what it will do, if you look into this 10 and the next number is 17.5. What is the difference there? 7.5. So every number will have the equal distance. Now let's check 17.5 and 25. The distance is 7.5. 25 to 32.5. Distance is 7.5. This to this 7.5. So all are equally distance or maintaining the equal distance. So it's ending at 40. It started at 10. So what it does, even though you give instead of a 5, you give 10. So what it means that I want 10 elements between 10 and 40, which are linearly spaced, which should have equal distance between one number to the next number, this number to the next number, this number to the next number. Let's execute this. So 10 started from 10 and you check the distance or the space between this number to this, it's 3.333 something. Then this number to this, it will be equal distance. This to this will be equal distance. That is basically what linspace or linear space. Maintain the equal distance in layman term. Right? That is what the linspace. Now, let me keep this 5 as it is. Then the last point here. So I'm saying linspace starting point, end point. Within this range, I want 4 elements. I want 4 elements. This is nothing but 5 is this is the parameter it takes. I want 4 elements. So I'm saying end point equal to true, retention step equal to true. What are these? Right? Let's try to understand. So whenever you want to print end point, you can say true. If you don't want to print end point, you can say false. We'll work on that. We'll execute multiple times with different options. This retention step equal to true. So this also we'll discuss. Sometimes what happens, we don't know the distance between one point to another point. We'll talk about that as well, one by one. Let's print this. Now, starting point 2, how many elements? 1, 2, 3, and 4. So this part is done. Starting point 2, yes. End point is also included. Why it is included? Because end point equal to true. Even though you don't give this, by default it will print. Now what I'm going to do, I'm going to say false. Okay. Now I'm going to execute one more time. Now if you look into this result, started from 2, right? But it did not included the end point, because I'm saying end point equal to false. So it will be maintained that way, such a way that it will not consider the end point. Now coming back to this retention step. So here it is very easy to identify the distance maintained. How much is the distance between one to another, right? So we can clearly say 0.25. 0.25. If you don't know how much is the distance, so you can say retention step equal to true. So here you will see this is the distance it is maintaining. Sometimes we need this because, let me put this, okay? Give me a second. What I'm going to do, I am going to take this, okay? Give me a second. Copy and I'll just paste it. Then what I will do, I will say 4 and 25, and here I will say I need 39 elements. All right, let me print this. Now can you figure out the distance here? It is difficult, right? Distance between 4 to 4.55263158. So here you can see one number to another, right? So even I can make it a little complicated here. 4.5678 and 25.9836. Some number. Now it is much more difficult, right? So if I ask you what is the distance it is maintaining, you have to calculate. Take a calculator and have to think it. Manually you can do without calculator, but it takes time, right? So in that case, I don't know what is the distance it is maintaining between one number to next number. So how do I find out? So that time what I will do, I will take this, right? I will take this and I will just give retention equal to true. Now it is maintaining, you can see this. This is the distance it is maintaining. Without I manually calculate, I will be able to find with this particular parameter. This is what it is displaying. All right, that is basically what ret step.